All right, so next thing that we're going to talk about is section 6. And in here, we're going to discuss a few things. We're going to solve quadratic equations that do not have a linear term, so that do not have just the variable x in it, the linear term. And then we are going to talk about completing the square. All right, it will be broken out into a few videos for you. So the first thing here we're going to go through is when we were learning solving quadratics before, the only method we have learned so far is solving through factoring. And when we want to factor, we want to make sure that this is set equal to 0. So we'll subtract 46 from both sides to cancel out that, and then we get 46 here. All right, and then 4x squared, and then 10 minus 46 is minus 36 is equal to 0. All right, and then from here, we want to factor. So the first thing that we always look for in factoring is our GCF. We have a 4 and we have a 36. 4 goes into both, so we can factor out that 4, and then we're left with x squared, because we just divide each one by 4, and then we're left with x squared minus 9 is equal to 0. All right, so now we can get rid of this 4 by dividing each side by 4, because we want to start isolating that x squared, and now we have x squared minus 9 is equal to 0. All right, and remember, when we only have two terms and we're trying to factor, we look at the sign that we have. If it's a minus sign, then we try and see, can we take the square root of each? Well, the square root of x squared is x, and the square root of 9 is 3. So when we can take the square root and its subtraction, it's the difference of two squares. So when we factor this out with our two factors, set it equal to 0, we write our two factors that we got, and it becomes plus and minus. So that's our factored form. And remember, anytime we have two factors that multiply to equal to 0, that means one of them has to be 0, so we set each of them equal to 0. X plus 3 is equal to 0, or x minus 3 is equal to 0. We subtract 3, so x is equal to negative 3. We add 3, or x is equal to 3. All right, so that was the method that we learned before. We solved it through factoring. All right, but whenever we don't have the linear term, so whenever we don't have that x term, so we have the x squared but no x, we don't have to factor. All right, we can just isolate that x squared. So if we have over here 4x squared plus 10 is equal to 46. So we treat the x squared like it's an x, and we want to isolate that. So then that means we need to get rid of the plus 10, so we subtract 10 from both sides. Cancels out, so now we're left with 4x squared is equal to 36, and then we'll divide each side by that 4, so we isolate that x squared, so it means x squared is equal to 9. And now, once you get this all by itself, the next thing that you have to do is we want to solve for x, not x squared. Well, the inverse of x squared is the square root, so then we take the square root of each side. And this is the one thing that you have to remember. Right? It's not that x is just equal to 3. It's x is equal to plus or minus the square root of 3. Because what we have written here is some number squared is equal to 9. So that means some number times itself twice is equal to 9. And I know if we multiply a positive by a positive, that's equal to a positive. And a negative times a negative is also equal to a positive. So we need to make sure that we include both the plus and the minus for this. All right, so this will be our final answer. So if you want, you can still factor it through solve it, or you can still solve it through factoring, or you can isolate the x squared like you would a regular variable x and then take the square root at the end. All right, we're going to do a couple more problems for this. All right, so the next example we're going to do is 3x squared minus 5 is equal to 25. All right, we're only going to solve these from now on by isolating the x squared and taking the square root. If you want to factor, you can do that one, but not in this video. All right, so then from here, if we want to isolate, since it's minus 5, we want to add 5 to both sides. So then we get 3x squared is equal to 30, 25 plus 5. Then we need to divide each side by 3 to get rid of our 3. So then we get x squared is equal to 10. All right, once we isolate that 10, we then can take the square root of both sides. So we isolate that x. We can take the square root of both sides, so our inverse operation of x squared, and we get x is equal to plus or minus. All right, now the square root of 10 is not a perfect square, so we can't just take it like we did the last one. So here we will leave it as the square root of 10, and you need to try and simplify it if you can. The square root of 10 does not simplify, so this is our final answer. All right? One more example, then we're done with this. All right, so this is another type of problem that we can solve. So here we have x squared plus 4x plus 4 is equal to 25. All right? If we want to do it the original way that we learned, we can solve each side by factoring. So we can subtract 25, and we get x squared plus 4x minus 21 is equal to 0. This sign tells me that they are going to be different. So I can write my two factored forms, and I can write it as x plus and x minus. And now I'm looking for numbers that multiply to 21 that have a difference of 4. And 7 times 3 is equal to 21, and 7 minus 3 gives me 4. So I know these are the numbers I'm going to use. Right? And remember, whatever sign is here, our bigger number has to follow. So since that's a positive, our 7 has to be positive. So it's x plus 7 and x minus 3. So then if we want to solve this, we can take our two factors and set them equal to 0. So then we can subtract 7. We get x is equal to negative 7. Or then we do x minus 3 is equal to 0. Add 3. And x is equal to 3. Right? That is solving using the original method that we learned of just factoring. Right? But if we look at this problem here, we have, remember, whenever we have three terms, if we look and see that this is a plus sign, and that the first, our first term and our last term are perfect squares, so the square root of x squared is x, the square root of 4 is 2, and we multiply these two together, it gives me 2x, and then we double it, that gives me 4x. Remember, this matches our middle term. That means we have a perfect trinomial square. So another way that we can solve this problem, x squared plus 4x plus 4 is equal to 25, is if you look here and you notice, well, I have a perfect trinomial square, as we just showed here, and I have a perfect square here. So whenever you have it equal to a perfect square and you have a trinomial square, what you can do is factor this out. So remember, when we can do this, and we can use our perfect trinomial square, we write our factor, we know it's going to be squared, and then our two square roots, x and 2, get written, and then the sign here drops and goes with our number. So it's x plus 2 squared is equal to 25. So just like in the problem before that we were able to take the square root of x, I can take the square root of x plus 2 squared. If I take the square root of that, it will undo my radical. It'll undo my square, so then I need to do it to both sides. So now I have x plus 2 is equal to, and remember, any number squared means we have two of them, a plus or minus, so we have a plus or minus 5. All right, so then that means we can rewrite this as x plus 2 is equal to the positive 5, or x plus 2 is equal to the negative 5. All right, we subtract 2 from both sides. X is equal to 3. We subtract 2 from both sides. Or x is equal to negative 7. All right, so that's another type that we can solve this for. So we have solving by isolating our x squared and taking the square root. And then we can also, when we have a perfect trinomial square and a number that's a perfect square, we can then set it up as x plus 2 squared is equal to 25, and we can take the square root and solve it this way. All right, just remember, you have to put plus or minus here, because we can have two negative numbers will multiply together to give me a positive, and two positive numbers will also multiply together to give me a positive. All right, that's it for this video, and then there's one more video.